For number 53, we have basically exactly the same, but instead of the carbonate, we have the sodium carbonate, which is the base. And it is 10 milliliters, again, 0.1 mole per liter, and it's being titrated by HCl 0.1 mole per liter. By the way, we can strictly or very fast find the volume at equivalence, the first one and the second one. 10 times 0.1 equals to 0.1 times VE. So basically VE is basically 10 ml with 2 VE needed to neutralize all the acid is 20 ml. Okay, let's keep this in mind. Write the hydrolysis reactions of the dibase and KB1, KB2. Calculate the pH. Denote by X equals VA على V equivalence. Write the corresponding reactions and calculate the pH of the medium for 1.2 and 2. Calculate the pH of the medium for 6 and 10. And we have pKa1 given as 6.3, pKa2 given as 10.3. Okay, let's start. واضح. 53, we're gonna do it here. 53, part A. First of all, we have to write the hydrolysis reactions and specify KB1 and KB2. It's a dibase, so dibase Na2CO3. This is a salt. It will go into 2Na plus CO3 2 minus. Now this is your active species. So the first reaction is CO3 2 minus with H2O to give you HCO3 minus plus HO minus KB1, which is equal to HO minus times the acid HCO3 divided by CO3 2 minus. Second reaction, you take the conjugate plus H2O, you add a proton, remove one from H2O. And this is KB2, which is HO minus H2CO3 divided by HCO3 minus. Remember, KB1, you can find it from pKa2. طلعوا على الcouples يلي موجودين. This is the second couple, not the first one. لأن نحن we always study them with respect to pKa's. KB2, you can find it through pKa1. Look at the couples. These couples belong to Ka1. Very good. So this is basically the first part. To find KB1 and KB2, خلينا نجيبهم because we're gonna need them. KB1 is basically, you know that Ka2 times KB1 he KW, KB1 he KW divided by Ka2, which is 10 to the negative 14 divided by, I think it's Ka2 10.3, negative 10.3. Again, find it, 1.99, I think 5 times 10 to the negative 4, ما في unit, it's KB. KB2 is KW divided by Ka1, 10 to the negative 14 divided by 10 to the negative 6.3, I think, which is equal to 1.995 times 10 to the power negative 8. It makes sense in the KB1 is greater than KB2. This is true. Okay. Part B, I think they wanted the pH of the pure base. So بما إنه في عنا فرق between KB1 and KB2 a minimum of 4 طلعوا على negative 4, negative 8, we can neglect the second basicity, which is basically reaction 2, and simply say that the pH is equal to 7 plus half, which pKa طلعوا على الكابل بأول reaction, this is couple 2, plus half log C. If it's greater or equal, then pKa2 plus 1. Again, 7 plus half pKa2, what was it? 10.3 plus half log. The concentration did not change. True, it stayed the same. بعد ما غيرنا شيء, the concentration is 0.1. Log 0.1 is greater or equal than 10.3 plus 1, so that's 11.3. Okay, you get an answer of 11.65. This is greater than 11.3, valid. This is your pH. Good. That's part B. خلينا نرجع بس نشوف part C and D. C is X. Write the corresponding reactions and calculate the pH for X equals 1.2 and X equal 2 and 6 and 10 ml. Okay, كتير منيح. خلينا نبلش بال 1.2 and the 2, 6 with 10. We can also find them from the X's. It's okay. So, part C. We establish the reactions of the pH with respect to X. Now, the only difference that you need to remember between bases and acids is that it switches. And I already told you to try to do the derivation, but if you look at the acid is X over 1 minus X, X minus 1 على 2 minus X. They just switch. So for the base, it's now 1 minus X على X, and for the second base, it's 2 minus X divided by X minus 1, okay? Basically, the axis switch and pKa is a switch. So, for a dibase, here it doesn't make sense when we say dibase. It's just like a base that originated from a diprotic acid. So, for X between 0 and 1, which is basically the second couple, you're transforming CO3 2 minus into HCO3. Your pH is equal to pKa2, again, it's the second couple, plus log the inverse of the acid, 1 minus X divided by X, because the limiting will axis are now inversed. The limiting and the axis are now inversed. For X between 1 and 2, for the second basicity, pH is equal to pKa1 plus log 2 minus X divided by X minus 1. Okay, so for X equals 1.2, it's 1 plus 0.2 before the second equivalence, but after the first equivalence. The pH is determined by pKa1 plus log 2 minus 1.2 divided by 1.2 minus 1. This is your pH, which is around 6.9. That's basically your pH. For X equals 2, this is the second equivalence point. You have H2CO3 in the system. The pH is equal to half pKa1 minus half log C. If it's less or equal, then pKa1 minus 1. Agreed? So, calculate this. أكيد remember to find the new C, because this is your خليني أقول the thing that you mistake. To find the C, which is H2CO3, use the conservation of mass by using the original concentration times the original volume divided by the total volume اللي هو كان 10 للoriginal solution with 20 عبارة عن ال VE1 and ال VE2. Okay, and this is basically 0.0334. Sometimes they don't need to give you the volume of the equivalence and you don't even need to calculate it. if you have the same concentrations, يعني CO3 minus is 0.1 and the HCl is 0.1, you know you need the same volume. So it's basically V plus V plus V, so 3V. The volumes cancel each other. So this is 3.88 less or equal than 5.3, and this is valid. هيدا الexample where they don't give you the volumes, it's in your previouses. So solve the previouses and you'll understand it very good. And this is x equals 2. What do we have left? 6, 10. We can very simply find them in terms of x's. For VA equals 6, يعني الx is equal to 6 divided by 10. Okay? X equals 10 divided by 10. Okay, so it's 6 divided by 10, 10 divided by 10. Part D. For x equals 6 divided by 10, because we calculated the volume at equivalence, this is basically 0.6. You use the first equation, اللي هي pH is equal to pKa2 plus log 1 minus 0.6 divided by 0.6. For x, y. For x equals 10 divided by 10, which is basically 1, ampholyte half pKa1 plus pKa2. And that's basically it. Okay? Try to find this using the traditional Henderson-Hasselbalch method by calculating the remaining species of CO3 minus and the produced species of HCO3. Understood? Try to do it using that method. If you cannot, then you ask the question so I can show you. It means that you still have problems with the traditional method, which you need to know. our slides because we already explained everything in the slides. So I want to do something here that they did not ask for it. Okay, I want to draw the curve the same way that we did it for H2A. So we're gonna draw the curve and separate the curve into areas, okay? This is your pH, this is the volume of the acid added. You start أكيد from basic, you go, no. Okay, this is your first equivalence. Your second, pay attention and know the volume of the first equivalence and the second equivalence, they have to be equal. Okay, so I will try to draw it as equal. Okay, so VE, 2VE, VE over 2, 3VE over 2, and let's say axis. Okay, doesn't matter how much it is. Let's say this is axis. So you start with only CO3 2 minus. We already know how to find the pH. The second important point here, VO over 2, which is basically HCO3 minus equal to CO3 2 minus. pH equals pKa2. Equivalence volume where you have HCO3 minus, pH is equal to half pKa1 plus pKa2. These are like the simplest points, okay? The second half equivalence where HCO3 minus is equal to H2CO3, pH equals to pKa1. The second equivalence point where you have H2CO3. كلنا صرنا نعرف إن ال pH هي half pKa1 minus half log C if the validity is correct. Excess of H3O plus. Okay, remember X between 0 and 1, X between 1 and 2, X greater than 2. Understood? خلينا نحط كمان the X's. X equals 0, X equals 0.5, X equals 1, X equals 1.5, X equals 2, X greater than 2. Whenever you have X greater than 2, simply find the H3O plus remaining in the system for this case, which is the original concentration. خليني أقول CB حتى ما نغلط C. Okay, بلا ما نحط CBVB. No, let's do CA, which is the concentration of the acid times the volume of the acid added minus 2VE. Okay, the volume that you needed to neutralize the first and the second acidity divided by the total volume of the system. Okay, and this is how you divide the pH of a dibase. Okay, and this is how you divide the pH of a diacid, which we already covered elsewhere. Okay, and this is basically it. With that, we finish acid base. Try to finish it as well and see if you have any questions before we start redox.